Alright, I want to make a video of just doing a couple examples of the transformations all put together. Kind of just showing you just a quick explanation of them. But these are the examples that you're going to be doing. So I'd rather just do just do a few problems of everything we're going to be doing. So for example, we're going to sketch this function, m of x is equal to negative 1/2 x minus 2 in parentheses squared plus 3. So like I said before, the first thing you have to be able to identify is, remember we went in order. So I'll write the steps on the left hand side. The first thing we want to be able to do is identify, we want to identify the parent function. So we want to identify the parent function. Then, remember, we work from inside and out. So that means we see if anything is multiplying to the function inside, and if there's a negative or any number between. If this number is bigger than 1, then that means you're going to do opposite of what you think you should do, and that means but it's gonna happen horizontally. So it's gonna shrink horizontally. Where if you multiply by 1/2 or something between 0 and 1, you stretch it horizontally. And then we're still inside, but now we're working with if we add or subtract inside. And don't forget, positive is left, negative is right, meaning the shifting of units. And then this is the inside, and then we move over to outside. And outside if something is multiplying outside of the function, either a negative or a number. This is a reflection on y, this is a reflection on x-axis. That's the y-axis, the x-axis. Here, where everything behaves the way it's supposed to outside. So if you multiply by a number bigger than 1, you're going to stretch this vertically. Whereas if it's in between 0 and 1, you're going to shrink it vertically. And lastly, we get all the way outside, and you add or subtract. And this behaves the way it's supposed to. So positive is up, negative is down. So those are the steps we're going to take to be able to graph these. So let me give you guys a graph. Now let's set up an x and y plane. Alright, so I'm just going to do a rough sketch. So I can identify the parent function because of this square right here. Because of this square, I automatically know that I'm going to be dealing with a parabola. That's going to be our parent function. And if you want, you can try to create a more precise graph, or you can just do a rough sketch of a parabola. You see, that's not perfect, but it's a rough sketch of a parabola. And that was the first step, being able to identify the parent function. Now, let's see if anything is multiplying to it. So if we see right here next to x, there's nothing there other than this invisible 1 right here. So there's nothing else in front of that x. So there, we don't have to do this one. There's no reflections going on. There's no stretching or shrinking horizontally. So now I move to if I should move it left or right. Now, let me get a different color for that. So there is something adding to it, or I mean subtracting by it. But this, you're going to do opposite of what you think it should do. Because since it's negative, we're actually going to shift it to the right. So that means I'm going to go over 1, 2, and this same parabola curving upward. Again, if you want to use the precise points, you can. But what's happening here is you're just adding instead of subtracting by 2 to the x coordinate. So what I mean is this ordered pair here, the origin of 0, 0 what we ended up doing is adding 2 to the x value, and that's why I'm at 2, 0 now. Where if it was plus, we'd have to subtract by 2. So it's the opposite of what you think it should be doing. So even though there's a negative in there, you're adding 2 to the x coordinate. So cool, we did that part. So we can check that off. That was fine. Now, let's try working a little bit more outside. And we can see on this outer part, there's a negative and this number. So we're gonna have to do both of these transformations here. So if you want, we can start with the negative. It doesn't matter which one you start with. You can literally start with any one you want. But the negative is pretty straightforward to see because it's a reflection on the x-axis. So that means everything, because what's happening here is all the y coordinates now are being multiplied by a negative. So any positive values, multiply them by a negative, they get brought down here. And then we could see a particular point. For example, we know right here, at this point, there's a point called 1, 1. And just like how we shifted over the origin, we're doing the same thing to this x coordinate. Instead of being 1, we're adding 2 to it. So it's right here now, and this is 3, 1. The y coordinate isn't changing, the x coordinate was changing. But now, with this scenario, what we're doing, you wouldn't be able to see the reflection with these 2 points, because multiplying the y coordinate by a negative, well, 0 times a negative is still 0. But now what I'm doing is I'm multiplying this x coordinate by a negative. So that new point is, instead of 3, 1, ends up going right here. And this ends up being 3, -1. So then when I make my parabola, I know I have to intersect that point. And again, I don't expect you to do a bunch of points. I just want to show you what's actually happening to the entire graph as we're going along. Now, what's going to happen next is that, so let me check it off. Or at least we checked off the reflection, but now we have to do, I'm going to do it in a different color. I'm going to do it in this color. We have to do this number that's being multiplied outside. And since it's multiplying outside, it's going to behave the way it's supposed to. And what I mean by that is, if we multiply by a number, any number by a half or a third or 2/3, any number between 0 and 1, it's going to make it smaller. But the way it's making it smaller is making it smaller vertically. I mean, since it's outside, what's going to happen is this parabola here is going to get squished down, and it's going to end up bulging out. But what's actually happening is I'm multiplying this y coordinate by a half. So it ends up moving up here. So I'm going to pull that out. It ends up being 3, -1/2. So that ends up making this parabola wider. And you can see that, okay, I kind of drew it funny, but there's that curve. Because if you squish this parabola down, it's going to bulge outward. But what's actually happening is you're multiplying all the y coordinates by a half. So it's bringing it vertically, shrinking it. And we can check that off. And again, I'll do another example. I'm just trying to go little by little through these so you see exactly what's happening along the way. And now lastly, here, hopefully these colors aren't throwing people off. Now we have to go to the very last part, which is there's something adding outside, and it behaves the way it's supposed to, meaning it's going to shift upward. So these points, so what we're doing now is that we're looking at our y coordinate and we're adding 3 to that y coordinate. So I'm adding 3 to this -1/2. So what ends up happening, I'm going to go up 1. Sorry, you can do it to here too. Or you can do it to this coordinate here, this 2, 0. You can move that one up 1, 2, 3. And then you can also move this coordinate up 3. So it'd be 1, 2, 3, and then you'll be able to see the graph here. Hopefully you can. There's the final graph, is this one right here. That's what this one represents, is that function. I know it's all cluttered up in there, so if I did it on the side, let's say if I drew another graph, I know I have a point here at 1, 2, 3, and then 1, 2. This is what the final graph looks like. It's a parabola pointing upward. That's pretty wide. That's this one. These two are the same thing. So again, it's just a step-by-step process, and just remember from inside and out. And don't forget, if it's inside, it's opposite of what you think it should do. If it's outside, it behaves the way it's supposed to. So let me do another example. Hopefully a couple more examples will be able to understand how these transformations are working. So now let's work with, let's say h of x is equal to, now we have negative 3 x minus 2 minus 4. So again, we're still going to go through the normal steps. So the first step was to identify. So remember these, if you want, write these down somewhere so you can have them. You first want to identify the parent function and then work from inside and out. So whatever's nearest to x, and then you start working your way out from x. So I can see these absolute values, so I know my parent function is going to be that v. So let's draw a graph so we can see this. So I'm trying to draw pretty big so we can see everything that's going on. 1, 2, 3, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, I'm trying to space them out a little bit more so not everything's cluttered up together. So I have to start with my parent function. So I know the parent function is the perfect V shape where all these coordinates, so for example here the origin is 0, 0. This point here is 1, 1. We even have the point here, which is 2, 2. So again, after doing these, you start to memorize what's happening. Or on this side is just negative 1, 1, and then the x's are going to be negative, and on the left-hand side, where the x is on the right, will be positive. But we have to see the first thing. So the first thing, check, which was identifying the parent function. Second thing is we have to see if anything is happening inside. So if that's either a constant or a negative to that x that's multiplying to it. And there's nothing there, so we can not do that one. And then the next thing is to see if anything is adding or subtracting to, well, because in this case we should say h, because this is h of x. We just see if anything is adding or subtracting. And we see that something is subtracting, just like before. So that means we're going to do opposite of what you think it should do, which instead of going to the left, it's going to go 2 to the right, and it's going to be right here. Again, and all that happened is that all these x coordinates, this 1, 1, this 2, 2, this 0, 0, we added 2 to it instead of subtracting 2 to that x. Okay, it's doing opposite of what you think it should be doing. So that's why this coordinate here is now 2, 0, and this coordinate here, which is the same one as this, is 3, 1, and so on and so forth. Because we're adding 2 to each x coordinate, but the y is staying exactly the same. Now we're going to look at, we start working our way outside to see if anything is multiplying either a constant or a negative to outside of the function. So same thing as before, now we have 2. So the negative, we can do the negative first. And the negative, what the negative does, it just does a reflection on the x-axis. It's going to look something like this. It's just a straight reflection. And now we have our 3. So we've done the reflection. We now need to do the 3, which this, since we're outside, it behaves the way it's supposed to. And the number is bigger than 1. So that means we're going to do a vertical stretch. So what's happening here is we're going to grab this and just sort of pull it downward. And what that ends up doing to this V shape, it ends up closing it down. But like I said, what it's actually doing, it's now multiplying the y by 3. Before we were multiplying the y by the half. Now we're multiplying the y by 3. So let's say here, so it ended up happening, this point ended up moving down here. And it just became 3 comma negative 1. Since we did the negative, means we multiplied all the y coordinates by a negative. But what's going to happen to this coordinate now, so let me use another color. So what's going to happen is that we're going to multiply this x coordinate by a 3. So negative 1 times 3 is going to give us 3 comma negative 3. So it's going to bring this coordinate down here. 3 comma negative 3. So that ends up doing, again, it's stretching it vertically. So if you had this V shape and you're pulling on it, it's going to end up narrowing it down, wanting to make a straight vertical line. But what's actually happening is you're multiplying all the y coordinates by 3. So that, I multiplied that by 3, hence that's going to give me negative 3. So it's comma 3 comma negative 3, and then you can see how that vertical stretching is happening. And lastly, we want to see if anything is adding or subtracting outside of the function. And there's a negative 4. So what that means is that we're going to end up bringing it down 4 units. So what we're doing here is now we're subtracting the y coordinate by 4. So right here, this point right here, this is, if you can't see it, but it's 2 comma 0. What we're doing to the y coordinate, we're subtracting it by 4. So that means it's going to end up being 1, 2, 3, 4. It's going to move down here, and that point is going to be 2 comma negative 4 now. Where this point ends up being 3 comma negative 7, because if I subtract negative 4 from 3, I get negative 7. So you're going to see that it's at 3, 4, 5, 6, 7. So that point, this one right here, shifted to 3 comma negative 7. And you can see how the shape is still the same. All it did, it got shifted downward. And this is the final product. That would be your h of x while you're sketching this graph. Again, if you want to use points to give you a slightly more precise graph, you can. But like I said, as long as you're doing a rough sketch, that's perfectly fine with me. You're shifting correctly, reflecting correctly. All those things are perfectly fine with me. Whichever works best for you, you can do that. But again, you want to go through these steps. These steps are helpful to see what's happening at every point in the function. But let me get an example that illustrates a couple different things. Let me get another sheet of paper, sorry for the long pause. I should have paused the video. I'm gonna do one more example so we can see what these functions look like. So here's another example. We're gonna go with g of x is equal to g of x is equal to negative absolute value of 2x plus 8. All right, so now this is showing something multiplied inside. I want to illustrate that example. So let's start with our graph. Oops, a little crooked. Again, a little crooked. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. All right. So first things first, you want to be able to identify your parent function. Just like we did before, it's the absolute value, which we know the absolute value is a v. And it's like a perfect v because it's 1, 1, 2, 2, 3, 3, 4, 4, or negative 1, 1, negative 2, 2, and so on and so forth as we're going through all the points on this graph. Or you can say a half, half. It's just on this side, the x and y coordinate are the same. On this side, the x and y coordinate are the same. It's just the x coordinate's a negative. So now the first thing we notice is that there is something multiplying. So again, I'm following the same steps, just not writing them down. That 2 is, now it's inside. So when something is happening inside, it's doing the opposite of what you think it should do. Since it's multiplying, and it's multiplying by a number bigger than 2, it's actually going to do a horizontal shrink. So what I mean by that is, let's say we take this point right here, which you know is 2, 2. What you actually are doing, instead of multiplying the x coordinate by 2, you're going to divide the x coordinate by 2. So again, it's opposite. For outside, when we multiply by a number bigger than 1, it's a vertical stretch. But when it's inside and we multiply by a number bigger than 1, it's a horizontal shrink. It's opposite. Because you would think numbers bigger than 1, when you multiply, make things bigger. But in this case, it's shrinking it. And the way it's shrinking it, it's dividing the x coordinate by 2. So that ends up shifting it over to here, where now the coordinate is 1, 2. And that's happening to all these coordinates here are sort of shifting. So for example, this coordinate here, that's 1, 1, is going to get shifted over to here, which now it's going to be 1/2, 1. And this is the way it's going to look. Because what's happening here, it's a horizontal shrink. So imagine you're collapsing this to the y-axis. What's going to happen? It's going to narrow out when you're doing a horizontal shrink. So cool, we checked that off. Now we have to move on to what's happening. So all we have is a negative outside, and we know what that negative does. It does a reflection on the x-axis. So it's going to look something like this. So again, I'm just doing a rough sketch. You don't have to do exact points, or if you want, you can. All that's happening is this point that's here. So this point ends up shifting down here because we end up multiplying the y coordinate by a negative. So instead of 1/2, 1, it's 1/2, -1. So it's just shifting downward, and you can see that. So, and then lastly, I probably should have not done something slightly different, but it's okay. We work our way all the way outside, and what is happening here is we're adding to our y coordinate 8. So this point here, if I add 8 to it, ends up being 1/2, 7. So that would be right here. 1, 2, 3, 4, 5, 6. It'd be somewhere up here. And then this coordinate here would be at 0, 8. Should be somewhere up here. Oops, sorry. Should be here somewhere. And then it'll look something like this. So what's happening here is this whole parabola here is getting shifted up 1, 2, 3, 4, 5, 6, 7, 8. So it's getting shifted 8. So again, it's the same graph. It's just getting shifted over 1, 2, 3, 4, 5, 6, 7, 8. I know I kind of skipped, but this is my graph. It's a little funny. But that's what's happening here. It's shifting it up 8 times. So just want to be careful. And the new example here was that it's giving that horizontal shrink that you want to watch out for. So just be careful with that. Follow these same steps, and hopefully you should be able to do these examples. If you're having trouble, please email me. Please send me a message through Canvas or come to my Zoom office hours. But let me give you some homework for this section. So you guys have some practice with these graphs, doing some transformations. So for 2.6, we have, let's do a couple examples I like here. Let's do 61, do 63. 63 is good, 65 is good, 66, 67, let's do 69, and let's do 75, 77. I think those are good. Try these examples for homework. Again, it's not too many, just 1, 2, 3, 4, 5, 6, 7, 8, I think. Yeah, 8 examples. Please try doing these. Email me if you have any questions, and I'll do my best to help. Thank you.